Good morning. Welcome, students. Good morning, all of you. And happy Sunday and happy Navaratras starting yesterday. So, I hope you're all doing great, students. So, coming to the last YouTube class for the month. This is the last YouTube class of the month. This class is actually, the heading goes with waveguides के problems. बट एक्चुअली हम लोग आज एंटेनास का लास्ट प्रॉब्लम है ये. दिस इज द लास्ट सेशन ऑन एंटेना प्रॉब्लम्स. सो होपफुली इट वोंट बी वेवगाइड्स टुडे. सो वेलकम ऑल ऑफ यू स्टूडेंट्स, वेलकम टू द क्लास. सो एंटेनास के फ्री स्पेस प्रोपगेशन इक्वेशन पे, इस पे प्रॉब्लम्स करेंगे हम लोग. दैट इज आई वांटेड टू अंडरस्टैंड टुडे एंटेनास and free space propagation equation along with polarization loss calculations, right? So welcome VT, good morning to the class, welcome. So just a few regular announcements. The UPL yesterday kal first exam tha, so quite simple exam yesterday. UPL league stage hua, so we got the upcoming sessions now coming on. So next week it will be a playoff stage and then the final stage. So the first stage that we have seen so far is the understanding of basic level exams, 30 questions of basic level. As soon as you come to the next stage, you will be getting better and advanced questions. So Ritam Bose, good morning. Mukesh, hi. Then this is the next big thing happening in Unacademy, rapid revision batch. You can see our team of faculty here. Rapid revision batch is almost for those people who have finished all the subjects. पूरे subjects एक बार हो चुके हैं, एक review से चाहिए उनको. So there is where it's very useful. So myself, Suresh VSR, and of course Srinath Reddy sir, you can see, equally experienced along with me. Siddharth Sabharwal sir, awesome ex-IAS officer. BV Reddy sir, ex-IITN. Then Sai Baba sir, equally experienced. So this forms a team of faculty for this. So we are the team handling rapid revision batch. So right now, of course, October 19th it is starting. So do join, do subscribe with my code for that. YouTube classes, of course, have come to an end now. It's all about problems in antennas and waveguides. So 3 classes in waveguides, 5 classes in antennas. So today's class is not antennas, it will be waveguides. It will be antennas, not waveguides. Last class of antennas, right? So last class this is, and this of course is the schedule in Unacademy Plus, Unacademy subscription classes. S parameters 1 class is over, 1 class is still due. MOS capacitor का आज class है, second class and the last class. So another 2 hours class today, MOS capacitor. And that will finish off MOS capacitor. So that's the second class today. आज 1 बजे को है. Right. Welcome Harshita. Welcome to the class. So any doubts, anytime, any details, anything that you want, feel free to WhatsApp me or follow my Telegram channel. So download the Unacademy learning app and use my name and follow me. That means you can follow with my name, Unacademy Learning app. So any details, anytime, feel free to ask me. Right? So regular announcements, regular points, regular aspects. Are you ready for today's class? Are you all ready, students? And I hope you're all enjoying waveguides problems. November also will be exciting like this. And hopefully November will go with antennas. I'm planning to take up a few theory concepts in antennas. So maybe as per the feedback I get, as per the requirements, I'll proceed. You can also give me some feedback. You can also tell me which topics you want. उसके हिसाब से हम लोग जाएंगे, right? So चलिए, let's start today's class. Tricky problems in antennas. And today's class we'll be discussing about these areas. Antennas part 5 is what it will be named. 4 parts are over now. So this will be part 5 and free space propagation equation पे. So majorly it is about polarization loss calculations and free space propagation equation. So watch out the first question. 1 किलोमीटर का क्वेश्चन है, वेरी बिग क्वेश्चन. So watch it out carefully. Question ध्यान से पढ़िए. Typical question on Friis free space propagation equation. 300 megahertz frequency, antenna gain is 8 dBi. The transmitting antenna gain is 10 dBi. And the transmitting power level is 25 watts. The distance is given between the transmitter and receiver. The power received at the receiving antenna port is, what is the power received? So you can see a very direct application of Friis free space propagation equation. You can directly apply it after a few terms are clear. इसमें कुछ terms पे clarity चाहिए हमें. The word 8 dBi, how much does it come to actually? Or 10 dBi, how much does it come to? So the gains are given. Gain is 8 dBi, decibels over isotropic. I hope you understand that 3 dB always corresponds to a gain of 2. So when it is 8 dBi, you have to correspondingly calculate it on a logarithmic scale. So 10 log the gain of the transmitting system, because I think it's transmitting system's gain. No, receiving antenna. Receiving antenna is 8 and transmitting is 10. So this is given to be 10 and 10 log gain of the receiving is given to be 8. This is the first thing you are supposed to do. Convert your gains into ratios from the decibel. एक बार रेशियो में आ गया, you can apply your formula. So before you get to it into the ratio, don't apply it in decibel directly. So ultimately GT is 10 even in decibel or ratio, whereas GR is 10 to the power of 0.8. This is how you express them as ratios. Any questions, anybody up to here? Any questions, anybody? So that's where the clarity is. 8 dBi, 10 dBi, transmitting power, frequency is known. All you need is to get your receiving power at 1 kilometer. So how do you get to the answer now? The answer is WR is equals receiving power, WR or PR, whatever you call it, transmitted power GT into GR by 4 pi D by lambda whole square. This is the formula that I expect that all of you know it. Friis free space propagation equation. So Friis free space propagation equation involves receiving power calculations for gains being given to you. So the received power is therefore transmitted power given in the question 25 into 10 into 10 power 0.8 by 4 pi. Distance is 10 kilometers, as you can see there. No, 1 kilometer. So 1 kilometer. So that's 1000 by lambda you have to find out for 300 megahertz. So 300 megahertz, lambda comes to be 3 into 10 power 8 by 300 megahertz is also 3 into 10 power 8. So lambda comes to be 1. whole square. That's the answer, Mukesh. Thank you for the answer. That's the answer. So this should be coming to be 9.97 microwatt. And as a student, if you don't know this, there is no meaning of handling this question. That's the most vital formula you should be knowing. सबसे crucial वो formula है कि how do you get your received power from gains. This formula also has a different version if you write it in terms of capture area. इसी को अगर आप capture area में लिखेंगे तो PR is equals WR is equals PT capture area of the transmitter, capture area of the received by lambda d whole square. This is where 4 pi can be written in terms of capture areas. So both the formulas are equally important. Both the formulas make sense. कभी कैप्चर एरिया में चाहिए तो कभी गेन्स में चाहिए. This question everything is given in terms of the gain. So I think that's option B. Should be option B. Clear, students? कोई doubts? Any doubts you can ask me when you read this question in the meanwhile. ये question पढ़ते रहिए and ask me doubts now. Typical question again from Friis propagation equation. Similar question almost. If you got any doubts, ask me and keep reading the question in the meanwhile. This is an old question, not from GATE and ESE. It's from a PSU. BSNL JTOS 2009. So frequency यहाँ पे भी दिया हुआ है. Just like the previous question. Distance is given just like the previous question. The only difference is minus 30 dB milli power when the transmitted power is 1 watt. इस पे ध्यान देना है. That's critically tough to understand. 1 gigahertz you'll use it just like the previous. Distance you'll use it. You have to find out the gains of the antennas. You have to find out the antenna gain when transmitter and receiver are having identical antennas. Transmitter and receiver both have identical antennas, and antenna gain is what you need. So what is the data here, students? The data is that the received power WPR is equals minus 30 dB milli when your transmitted power is 1 watt. This is the most critical data. अगर question ऐसा नहीं दिया होता, there is no need of solving this question. You can solve it yourself. But the critical aspect in the question is PR is minus 30 dB milli. So minus 30 dB milli, what does it mean? If PR by PT is minus 30 dB into 10 power minus 3, when this is 1 watt. So 1 watt 10 power minus 3. So convert the decibel also now. 10 log PR by PT is minus 30 dB हटा दिया मैंने into 10 power minus 3. That's where the problem is over. So 10 log PR by PT, how much does this come out to be? And please work out only on this for dB. Please be careful here. Milli is already outside the dB. Milli is outside. So PR by PT is therefore 10 power minus 3 for this dB part, and again 10 power minus 3. Putting it to overall 10 power minus 6. That's where the answer is. So whenever you talk of decibel scale, be very cautious. Decibel scale हमेशा confusing है, ratio में बदलना. So converting into ratio is very crucial, important. So PR by PT is ultimately 10 power minus 6. We can even say that PR is 1 microwatt when the transmitted power is 1 watt. ऐसे भी तो बोल सकते थे. This is also equally right. But see the question they told, 1 watt transmitted power पे received power is minus 30 dB milli. Minus 30 dB बोलना फिर milli बोलना. That makes it very interestingly confusing. So that's where the answer is. I could reach my PR. You know, I could even told like this. PR is minus 60 dB when the transmitted is 1 watt. ऐसा भी तो बोल सकते थे. इतने तरीके हैं बोलने का. But they told something like this. See the question? Yeah. So the final logic is PR by PT is 10 power minus 6. That is because gains are identical, transmitter and receiver. So G square by 4 pi distance. I think distance is 10 kilometers, 30 kilometers. 30 into 10 power 3. 1 gigahertz. So 0.3. That should give you the answer directly. 400 pi is the gain. You may call it as 1256. Whatever you call it, 400 pi. The trickiness in this question is that minus 30 dB. If it is not minus 30 dB, I would have never discussed this question. Second important thing, Friis free space propagation equation कभी by heart नहीं करना है आपको. That's another major thing you should be doing. You should know the sequence of steps through which you get Friis free space propagation equation. जब theory पढ़ाई मैंने antennas में भी वही किया था. I told you not to by heart this equation. This equation. इसको by heart नहीं करना है. इसका एक टेक्निक होती है. Steps होते हैं. You're supposed to be confident. So clear with the problem, students? 2 problems, quite simple, direct application based. Come to a question now which is something more interesting. इससे थोड़ी interesting देखिए. Look at this. A communication system with transmitting and receiving antennas are vertically polarized. So they are perfectly oriented. And if it is a normal day, the received power is 1 milliwatt. But उसके बाद बारिश हुआ, पता नहीं क्या क्या हुआ, and the polarization plane has been changed due to rain induced depolarization. It's because of some conducting nature of water. Because of the conducting nature of water, the orientation of the electric field changes. So whenever rainfall occurs, there is a conductor coming in between, attenuation starts, polarization changes, electric field का direction change हो जाती है. So given all these aspects, in सबके बाद the receiving and wave gets rotated by 60 degrees. Receiving wave gets rotated by 60 degrees. When it reaches on the receiving antenna, the received power now will be, ये 1 milliwatt से कम होगा या ज़्यादा होगा? Will it be greater than 1 milliwatt or less than 1 milliwatt? That's a very vital thing. So ready students? Question समझ में आया? फिर से पढ़िए. With things being all normal, transmitting antenna, receiving antenna, both being vertically polarized, you get 1 milliwatt. If the polarization changes by 60 degrees, what will be the receiving power? So answer students. So answer हर्षित सिंह. इजी क्वेश्चन तो ठीक है, आंसर बताइए. आंसर हर्षित सिंह. इजी क्वेश्चन सर, बहुत आसान है. यस सर, ओ सर. आंसर. Look at the concept first of all students. The concept is that you have the earth most often horizontal, हर्षित सिंह मेरे को पजल्स मत बताओ, कॉस्ट डिक्रीजिंग फंक्शन वो ये पजल्स मत बताइए, आंसर बताइए. You find most often antenna to be vertical. This is a quite normal sense. So antennas are most often vertical when communication is onto the ground, not for satellites. Satellites के लिए नहीं, ground wave communication के लिए. So when it comes to ground wave communication, you find an electric field which is vertical to this conductor, and it reaches one more antenna which is vertically polarized. So this is the general situation that you expect. The electric field is vertical to the conductor, so that this is your transmitter, this is your receiver. Good. Harshit Singh, now your answer is wrong. Because you considered the question is easy, the answer is wrong. Cost function, ये function सब होने के बाद आंसर रॉन्ग है, राइट? क्वेश्चन इजी मानते ही अपने आप वो गलत हो जाती है. सो व्हाट इज दैट देयर सेइंग नाउ, दैट देयर इज रेन कमिंग हियर. बीच में बारिश आया. So because of the conductor, the electric field orientation changes, because the conductor automatically changes the orientation. So the logic is now ultimately that if this is your antenna, and perfectly oriented, you should have been getting 1 milliwatt. But now that it is inclined like this, field is inclined like this. Polarization का मतलब हमेशा electric field direction. Polarization is always electric field direction. That has become by 60 degrees. So that's where the logic is. The electric field is not parallel to the receiver. It's at 60 degrees. So induced electric field now is induced E dash is going to be the previous electric field into cos 60. जो पिछला इलेक्ट्रिक फील्ड है वो ये है, तो अभी cos 60 कॉम्पोनेंट इंड्यूस होगा, which is E by 2. I hope you got the point. So the electric field that is being induced is only half. Power is square of electric field. So power की बात कीजिए, it is square of E. The moment you say the question is easy, when it is logical, you go wrong. ये यहां तो मेरे को बोल दिया easy है, 0.5 है, एग्जाम में भी यही करेंगे तो that's what happens. You should have great levels of focus. हर्षित सिंह, वो easy आसान वो statements होते हैं ना, they'll always ruin your careers. Focus की एक level होती है, that is what not doing mistakes. इलेक्ट्रिक फील्ड का स्ट्रेंथ हाफ हो गया तो पावर ऑटोमेटिकली इट बिकम्स स्क्वायर ऑफ इलेक्ट्रिक फील्ड. सो द P dash now that's going to be there is by 4. So that's 0.25. Vignesh Khanna and of course Mukesh, Harshita Pandey, perfect. EMT is a different subject. It's not like networks and digital and controls. Oh, easy, kuch bhi karo, chalega. EMT is different, and for electronic students, it's really different. So you should be very cautious. Be cautious with EMT. So that's where the answer is, students. The answer becomes 0.25. So when it's 1 milliwatt, now it becomes 0.25 milliwatts. Clear? So any doubts? Right, look at this question now. What a big question. Dekho, GATE 2017. Question padhte thak jaoge. And solution is just very small solution. Such a big question. And the most funny thing is numerical data question. कोई guesswork, कोई options भी नहीं है. So perfect numerical data question. Everything in the question. Friis free space propagation equation का one of the best question. I think the first thing what most students do is ये हॉर्न एंटेना वर्ड पढ़ते हैं फिर क्वेश्चन छोड़ देते हैं. हॉर्न एंटेना सर हम पढ़े नहीं, छोड़ दो. वहां पे हॉर्न एंटेना हो, डिश एंटेना हो, डोंट वरी. ये सबसे यूजलेस डेटा है हियर. दिस इज द मोस्ट यूजलेस डेटा. हाँ, डिस्टेंस इन लैम्डा फॉर कैंसिलेशन, ईज ऑफ कैंसिलेशन. Receiving and transmitting antennas 0.15 and 0.18 important. ये important है because the reflection coefficients being given there, that's one thing that should understand, that gamma for the voltage is 0.15. So reflection coefficient for the voltage being 0.15, voltage or current or whatever it is, mismatch. अगर आप power reflection coefficient calculate करेंगे, square of voltage 0.1115 whole square, this is 0.0225, which means that transmission coefficient for the power is 0.98. So 98% is being transmitted. So you can ignore this 0.15. मतलब ये mismatch का जो गामा है इतनी कम है, you can almost ignore it. 0.15 को ignore मत करो. I'm not saying that you can ignore the 0.15. You can ignore it because the power calculations when you take, it just comes to be only 0.02. Transmitted power is 98%. So this is the first caution I want you to take. So that's where the logic is, students. कि इस क्वेश्चन में reflection coefficients at the terminals of the transmitting and receiving antennas ये लाइन का ज्यादा कोई इंपॉर्टेंस नहीं है, unless and until you are a big scientist. अब रही बात इस फर्स्ट लाइन, ये भी तो इंपॉर्टेंट नहीं है. नेक्स्ट, द डायरेक्टिविटीज ऑफ द ट्रांसमिटिंग एंड रिसीविंग एंटेनास, ये थोड़ी क्रिटिकल हैं. 18 and 22 dB ये गेन्स हैं, एंड 2 watts इज द ट्रांसमिशन पावर. 2 watts एंटेना को कनेक्टेड पावर है, एंड ऑफ कोर्स polarization is matched. I want the receiving power. इतना इंग्लिश के बाद देखिए, see the minimum data it has got. Just see the minimum of the minimum data it has got. 200 lambda is important, 18 dB and 22 dB is important, 2 watts is important, and that's it. इसका तो कोई रोल ही नहीं है लेकिन बहुत कम है, बहुत कम रोल है. So 0.15 and 0.18, they give you reflection coefficient for the voltages considerable but not for the power. Now come to the arrangement, look at the question, look at the arrangement here. The arrangement says that there is an antenna here, and then there is an antenna here. They are separated by 200 lambda, and their gains are 18 and 22 dB, and here the mismatch is negligible. Here also the mismatch is negligible है. गामा यहाँ पे भी लगभग 0 मान लीजिए पावर का, यहां पे भी 0 मान लीजिए पावर का. And most important here, 2 watts is the transmitted power. So therefore received power is just nothing but transmitted power 2 into 10 power 1.8 into 10 power 2.2 by 4 pi distance by lambda whole square. If you are very strict about with the answer, बहुत ज़्यादा strict हो आंसर से, you can multiply here 0.98 और accurate आ जाएगा, which is because of the 0.15 गामा. एक 0.18 वाली गामा भी है, इसका भी पावर रिफ्लेक्शन कोएफिशिएंट निकाल लीजिए, which is going to be 0.18 whole square. उससे ट्रांसमिटेड पावर निकाल लीजिए टाउ पी, So you can multiply with those factors which are very close to 1. So physically, I am not saying that you leave the answer here. You can in fact multiply with the factors here as per what you feel is as per the 0.15, 0.18, which are coming very close to 1 only. So you can leave the answer like this. But the question has been made deliberately lengthy. इस पूरे arrangement के बाद the question has become deliberately quite lengthy. Quite lengthy. So that's where all the data is crucial. That's where the entire data is crucial here. See? Any doubts, anybody, students? Any questions? So if you apply these also, you will exactly get it 2.99 milliwatts. If you apply the transmission and reflection mismatch also, that comes to be perfectly 3 milliwatts. Right, exactly. इस बार सही है. हर्षित सिंह इस बार सही है. Now look at this. Old ISRO question. Just see now how you handle this. So everything again clear. Gain is 10 dB antenna का, transmitted antenna का. Polarization path loss, वो डिनोमिनेटर का जो भी टर्म है फ्रिस स्पेस प्रोपगेशन इक्वेशन में 100 dB. ओनली डिफरेंस इज ये सर्कुलर पोलराइज्ड एंटेना, receiving antenna is linearly polarized. This makes an impact. Transmitter is circularly polarized, receiver is linearly polarized. That should make an impact. So the logic is this, students. You are having here circularly polarized antenna and you are receiving here with linear polarization. So obviously this is sending in two components. Sending in two components का मतलब क्या हुआ? एक EX, एक EY. What does the linearly polarized antenna do? It receives only one component. और वो भी इधर वर्टिकल बोला उसने, so it will receive only EY. So that's where the logic is. The received power further reduces by half, further reduces by half, because of the two components you are receiving only one. दो components में से फिर एक ही receive कर रहे हो. So of the two components the electric field will become 1 by root 2. The power will become half. So that's where the logic is. कि transmitted power, received power is transmitted power into gains by 4 pi d gt gr by 4 pi d by lambda whole square. This is called as path loss. and this is already given 100 dB. There's no argument about it. This is already given to be 10. This is already mentioned. बस हमें ये चाहिए. Provided you know what is GR. So what is this antenna doing here? What is the antenna, receiving antenna doing here? It's having a polarization loss. Gain से ज़्यादा उसमें polarization loss ज़्यादा है. So therefore, you have to replace this gain with polarization loss factor. यहाँ पे receiving antenna में gain से ज़्यादा there is more than the gain a polarization loss. That's a crucial thing. Any questions, anybody? Absolutely, Mukesh. Mukesh, there's no doubt in it. So that's exactly Harshit. Harshit, यही आंसर है कि सबसे क्रूशियल लॉजिक यहाँ पे ये पोलराइजेशन लॉस फैक्टर है. So the final answer is this ultimately, students. The final answer is that PR is equals all in decibels. So you can simply add them. You add those values. You can add those values directly with 10 dB, 100 dB, 10 watts. 10 watts also comes in decibels. So if you added 10 plus the gain 10 minus 100, ये polarization loss factor is still left out. Minus the polarization loss factor. ये polarization loss factor जो है अभी half आया मेरे को, which is what is minus 3 dB. So decibel scale में half becomes minus 3 dB. Log 1 by 2 10. Log 2 is 0.301. So the answer will be subtracting all these terms, it's minus 83 dB watts. I hope it's clear. Harshit saying, sure, antennas next month in YouTube I'm considering. Surely will consider. Otherwise in special classes I'll take antennas. Either in special classes or in YouTube. दोनों free में ही I'm taking up antennas. Schedule I'll announce it in my Telegram channel. इस पूरे डिस्कशन का लॉजिक ये है कि ये सर्कुलरली पोलराइज था, ये एलिप्टिकली पोलराइज हुआ तो, अगर ये एलिप्टिकली पोलराइज हुआ तो क्या करते थे? That's my question now. ये सर्कुलरली पोलराइज्ड है, so EX is equal to EY and you're receiving only EY, so polarization loss factor is half or minus 3 dB. My argument is ये अगर elliptically polarized हुआ तो EX will not be equal to EY, and suppose if you are receiving only EX, then how do you calculate polarization loss factor? Sir, components का ratio निकाल लेंगे हम, ratio of components you will get it. Yeah, that's also fine. Ratio of components निकाल सकते हो, but उससे भी आसान तरीका है. There's a much simple formula for it. कि polarization loss factor is always mod of cos theta square. It's mod of the cos theta whole square, where cos theta is the angle between the transmitted electric field and the received electric field. ये सबसे इंपॉर्टेंट लॉजिक है. सो पोलराइजेशन लॉस फैक्टर जो होती है वो सर्कुलर टू लीनियर के लिए हाफ है, डायरेक्ट है. बट व्हाट इफ यू कंसिडर एलिप्टिकल एंड सच थिंग्स, then you should need a formula, and that formula is mod cos theta whole square, so that every time in Friis plus propagation equation you will multiply this. हर बार Friis plus propagation equation में PR is always equal to PT GT GR by the LS loss, spatial loss, multiplied by polarization loss factor, where PLF is mod cos theta whole square. What if theta is 90 degrees? Theta 90 degrees का मतलब perfectly orthogonal, vertical horizontal, एकदम orthogonal है, transmitted and receiver. PLF is 0, cos 90 0. So total received power becomes 0. What if theta is 0 degrees? Perfectly oriented, perfect polarization. PLF is 1. So PLF is always less than or equal to 1 and always greater than 0. So polarization loss हमेशा कुछ ना कुछ reduction ही है. It always results in reduction. And the reduction is from the maximum value, which is this is the maximum value. So इस फॉर्मूला को ध्यान से देखिए तो what I feel is PLF is therefore mod E transmitted का यूनिट वेक्टर डॉट E received का यूनिट वेक्टर का स्क्वायर. इलेक्ट्रिक फील्ड्स के बीच में एंगल का स्क्वायर पावर. The angle between the electric fields square will give you the power. So that's where it is for circular polarization. Ex plus JAY का unit vector root 2 dot AY square. That's the answer. So जहां पे फ्रैक्शन निकालना मुश्किल हो जाती है, where the fraction is really tough to calculate for elliptical and all, it's very useful. Circular, I don't need this formula, I can write half directly. Elliptical, it's crucial. Elliptical जैसे it's ax plus 4j, तो ratio is changing. So if you watch here carefully, this is just nothing but ax dot ay is 0, j into ay dot ay is 1 by root 2 का square, which is half. So that's the answer. ये किसी भी केस में काम आएगा भी. You look at this being linear and linear, but horizontal and vertical, dot product is 0. दोनों सेम ओरिएंटेशन, डॉट प्रोडक्ट इज 1. एलिप्टिकल हो तो भी काम आएगा. सपोज इफ इट इज y कॉम्पोनेंट इज 4 times x कॉम्पोनेंट, y कॉम्पोनेंट इज 4 times, तो यहां पे चेंज आएगा. सो देन यू विल राइट ay इज 4 times ax मान लीजिए, एलिप्टिकल पोलराइजेशन मान लीजिए, तो PLF क्या होगा यहां पे? मॉड ऑफ ax plus j4ay by root 17 dot ay का स्क्वायर. तो फ्रैक्शन इज चेंजिंग ना, ये आपका रिसीव्ड पावर में आएगा. सो एलिप्टिकल हो, सर्कुलर हो, अनइक्वल फ्रैक्शंस हो, इक्वल फ्रैक्शंस हो, वेरी यूजफुल. आई होप यू गेटिंग द पॉइंट. So the answer will be 4 by root 17 का square, 16 by 17, which is almost maximum power because vertically polarized. and vertical component is powerful. So जितनी vertical component है उतनी fraction आपको मिलेगा, इसीलिए formula बहुत जरूरी है. This formula is very vital. Any questions, students? Any doubts? So that's all for today's class. If you got any questions to ask me, stay back. So November month YouTube classes come to an end with 5 classes in antennas and 3 classes in waveguides. Purely problems. Purely problem oriented sessions we had. So कोई भी doubts हो तो you can ask me, otherwise I'll log out. If you got any doubts, ask me, otherwise I'll log out. So get ready for the UPL next stage. So get ready for the UPL next week. This has been over. League stage ho gaya. Next stage is this. Then of course finals is there. So that's about the rapid revision batch. Starting 19th October. So get ready for this. I think tomorrow it's starting. So if you got any doubts, you can ask me. Kana Mishra bhai, Rohit bhai. So YouTube classes have come to an end for this month. We are left out with only special classes now. Ye ho gaya. 3 classes on this and 5 on this. VT bhai. Ritam Bose. Shashwat, antennas schedule, please stay tuned with my Telegram channel, or you inform me which topic actually you're interested in. As per the feedback, or otherwise I'll create a poll in Telegram channel, answer the poll, accordingly I'll go. But November YouTube classes I'm planning for antennas only. So I'm planning maximum for antennas. Bhupender Singh, how much computer organization is important for GATE? पहली बार है ना, तो प्रेडिक्ट नहीं कर सकते हैं. मतलब किसी को भी कुछ बनाने के लिए मैं कुछ बोल सकता हूं. As a YouTube teacher, I do it frequently to give validity to things. मतलब YouTube में आजकल बहुत ज़्यादा एनालिसिस हो गया. वो एनालिसिस, ये एनालिसिस. So please don't, Bhupender, don't guess anything now. Computer organization कितना important है guess नहीं कर सकते हैं. पहली बार है ना. गेट पेपर, गेट के जो डेटाबेस हैं उससे कितने क्वेश्चंस पिकअप करेगा वो कंप्यूटर भी नहीं बता सकते हैं. हम कैसे बताएंगे? So don't take any such choice. Thank you Mukesh. Thanks a lot for staying with me always, Mukesh. You've been always great staying with me. Thanks a lot. So Bhupender, don't think of weightage of computer organization and all. अभी मुश्किल है. या रितम बोस, ट्राइंग फॉर एवरीथिंग. एंटेनास कंप्लीट कोर्स के लिए प्लान कर रहा हूं मैं. सो श्योरली आई सी हाउ मच आई कैन पुट इट इन यूट्यूब. श्योर. या मुकेश, 1 o'clock देयर इज मॉस कैपेसिटर क्लास. 1 o'clock देयर इज मॉस कैपेसिटर क्लास. सो दिस मंथ स्पेशल क्लासेस अनअकैडमी फ्री क्लासेस में ये एक क्लास रह गया, ये क्लास रह गया. दिस आई एम फिनिशिंग टुडे. This hopefully in this week I'll finish. ये भी इसी हफ्ते में होगा. I'll finish in this week. Yeah, thank you Golak, thank you. Polarization loss factor के questions पे ना वो formula directly apply करने से हो जाएगा. Rather than thinking कि PLF क्या है. You apply the formula by physically understanding what polarization loss means. It's good, it's good. Surely Harshit, surely I'll consider. हर्षित, अभी नवंबर 1st को मोस्ट प्रॉब्ली विल स्टार्ट द यूट्यूब सेशंस और इधर इन स्पेशल क्लासेस इन अनअकैडमी. पक्का एंटेनास तो होगा. मेनी पीपल आर आस्किंग. सी पूरा वेवगाइड्स व्हेन आई पुट इट इन वेवगाइड्स, एंटेनास इज नॉट अ बिग डील फॉर अस. श्योरली. So any other doubts? Feel free to follow me. This is my WhatsApp details and such things. Sure, Bhupender Singh. Bye students. Good day. Happy Sunday.